Then, libog-libog yun.
Having a problem in simulating a circuit?
Don't worry, use multi-sim 14.3.
Introduce NI Multisim 14.3.
NI multi-sim 14.3.
NI multi-sim 14.3.
This time, we are going to show you how to use this app to enhance and to improve your electrical designs prototype.
So this app is called NI Multisim 14.3. It is an industry standard spice simulation and circuit design software for analog, digital, and power electronics in education and research.
Why do we need to use this app?
First, it will make our imaginary circuits design into reality. We can share, collaborate, and discover circuits and electronics online.
Second, this app is an easy-to-use circuit teaching environment that simplifies circuit design by abstracting the complexity of spice simulation with a fully interactive simulator.
And lastly, this will help us instantly analyze and visualize electronic circuit behavior.
Now, let's begin.
So, this is what it looks like when you go or open the application. As you can see, it is just like an worded app. Again, so in the first layer, we must consider or we must know that this is also known as a menu bar. This is where you can access everything. Again, so in the second layer or in the second bar, it is also known as a standard toolbar where you can see all the components, where it came from, and what its uses. Okay, this here, the tools. This is the part. And in my upper left part, this is what we call the design toolbox or the design toolbar, where all the design happens, or where all the design that you have saved already store. Okay, so this is the part. So as you can see in my right part, in the border part, this is what we call the instrumental toolbar. So by the word itself, it is really needed, or it is the most, or it is the main thing when it comes to creating a circuit, because without this instrument, you cannot measure or you cannot identify or if it is or if it has a continuity within your circuit. Okay, so all the things that I've said is nothing if you didn't appreciate this one here. This is not just an ordinary whiteboard. This is not just an ordinary paper, but this is also known as a circuit board. This circuit board is where the place where the magic happens. At the time that you will create your design, create your own simulation, create your own ideas, will be placed in the middle.
So the first example that I'm going to show you is the series parallel inductor. So first we have to select a component, then go to all groups. Then first we find the DC power, then input the resistors. Let's go find the resistor. Here, resistor 1. Next is resistor 2. So we're going to put 3 resistors in this circuit. Then next, we go to the inductor. That one. Then we're going to find the switch. Here's the switch. Sorry for my mistake. Here. Then after that, we're going to connect these components together. The DC power, we're going to connect it to the first resistor, or the resistor 1. Here it is. then the resistor 1 to the switch. Here. Then next, let's rotate the resistor 2 so that we can connect it to the switch. Here, rotate it. Also the resistor 3. There, perfect. Then next, we have to rotate again the resistor 3 so we can connect it to our resistor 2 and to our inductor. Here. Let's connect our inductor, then connect it to our resistor 3 or the third resistor, then the third resistor we connect it to the second resistor, and then connect it to the DC power. Then let's connect our ground. After that, we put the multimeter. So the purpose of this multimeter is to measure the current and the voltage of our circuit. So let's put 3 multimeters. Last one. There. So the last step, we have to measure it. So let's run our circuit. Let's go find where to run it. No. So let's click the run, design. No. Oh my god, sorry. Let's go to design 2. Design 2, sorry for my mistake. Then let's go to run it. So the first multimeter, our voltage and our current. The next multimeter. So as you can see, it has 0 voltage because our switch is open. So if our switch is closed, our voltage is 4 volts. So that's it. Thank you.
Now, we will make charging and discharging capacitor circuit. So, we will take first of DC power supply. Click DC power and put this. After DC supply, we need to check our capacitor. So, select capacitor rated and we put this. After we have checked for the capacitor, go for our resistor. And for our grounds, select basic, then find switch and click this and put this. So after that, we will right click on it and we will click on rotate in 90 degrees clockwise. We can change this value of capacitor into 100 microfarad, and we can change the value of resistor into 100k ohms. Then connect DC power and switch into the capacitor. And this. Then connect resistor into the capacitor. And don't forget the ground. Now, we need the multimeter to observe the charging and discharging. Connect the multimeter on top side and negative side of multimeter. Now, we'll run. We can see there is zero voltage because switch is not pressed. So, when we press the switch, we can see the voltage. If we open the switch, now you can see that our voltage dropping little because the capacitor is discharging via 1000k resistor ohms. Now, we will see the result. The voltage is dropping. If we increase the value of the resistance into 1000k ohms, now we will run. There's a 12 volts. If we open the switch, we can see that the capacitor slowly discharges. Now, you can see a lot of line there is slowly discharging because we have increased the voltage of the resistance.
So this time we will be going to prepare RC analysis circuit. Okay, so first things first, we should go to select a component, go to all groups, and type AC power circuit or AC power source. Okay, and after that we should plot it down in the circuit board. Next, we'll be going to search another component, which is a rated resistor. Okay, type this, choose plot, and after that we'll be going to search again another component, which is capacitor or rated capacitor, or actually it's in your choice because it will be adjusted. Should ground also, plot it here. Okay, and after everything, all you have to do is just to connect everything up. Okay, and optional, you can change, you can set this to counterclockwise 90 degrees or counterclockwise or clockwise 90 degrees. Okay, so this time we will going to connect everything at the time that if you see this red line here, it means that this this circuit is already connected. There is a connection with among these circuits, but if you don't see this red line, it means there's short circuit or something. There's a warning. Okay, so on my right side, this is what we called oscilloscope. Okay, oscilloscope, it means that it is just reviewing oscillations and for electrical voltage. So we're this is what we called current amp. This is for identifying our current source or the current flow again. Okay, so the ground, so we will going to connect this negative from channel B to the ground, and from channel A the positive connection to the positive source. part of the source, this negative connection to the negative part of the source. So this channel B is connected to the current amp, which is you will find in the stimulate and at the bottom part. Okay, so from this part on, like I said earlier, that you can change the values of the capacitor, resistors, or even the sources. Okay, it's up to you. If you want to discover multi-sim, just be creative. Okay, so I'm gonna set this to like 100, just 100, and this 50 hertz. Okay, so as you can see, the circuit is already done. So if everything is done, all you have to do, or if everything is prepared, all you have to do is just to run the circuit. Okay, as you can see, at the time that the circuit run, and I double tap the oscilloscope, this is what we call, like I said earlier, this is the instrument that will show us graphically the signals of the voltage that change signals over time. Okay, so this is a part here. Okay, I run the circuit, and the red part is just to stop the circuit. Okay, so I run the circuit again. So this is what it looks like. This red graph, it means that the voltage source that is running with respect to time. Okay, and as you can see on the bottom part, it will show you after you run the circuit that there is 0 errors and 0 warnings, which means it's really good. It's a good circuit. Okay, so this is one way to prepare an RC analysis circuit by using oscilloscope. So this time we're going to create an RL parallel circuit and how to prepare it. Okay, so first things first, should choose the components. First component that we were going to search is our power supply or AC power. Okay, should go to basic or sources, it's up to you. AC power, plot it in, and after that should search another component, which is resistor or rated resistor. It's up to you because the value is changeable. The next component, so we're gonna type resistor, or I mean inductor. Okay, inductor, rated inductor. Okay, and after that we shouldn't forget the ground, because in every circuit ground is needed. Okay, here. So before you should connect everything, it's up to you that if you're gonna change the rotation of your resistor and your inductor to 90 degrees angle clockwise, it's up to you. Okay, like this one, gonna change your 90 degrees counter, or I'm sorry, I mean 90 degrees clockwise. Clockwise, I mean clockwise. This resistor 2 clockwise. Okay, so after that everything is good to go. So we're just gonna connect AC power to our R1, positive 1 and a negative 1 here. Okay, and after that the remaining components should connect L1 to R1. And as you can see, every time if you create a circuit, if the line will will appear red, it means that there is a connectivity or continuity between each components. Always remember that. After that one, I'm gonna get my oscilloscope 4 channels. This is different than before. Okay, oscilloscope 4 channels. I'm just gonna copy my ground here. Okay, so I'm gonna go to stimulate and choose the current clamp. One here. I'm gonna copy, and one for my resistor. Okay, and one for my inductor. So here. Okay. And after that, I'm just gonna move it a little bit. Okay. Okay. So I'm gonna connect the ground here. It means red. So there's a connectivity. There's a flow. And channel A to my source, positive source. Okay. And channel B, I'm gonna connect it to channel B to my first clamp. Okay. And my channel C in the clamp, the second clamp of my resistor. So this time, we're going to change the value of our sources, resistors, and even inductor. Okay, so I just set mine to 100 volts, 50 hertz, 0 degrees, and I will gonna change my value of resistor to 10 ohms. Okay, and change my value of inductor to 10 millihenry. Okay, and as you can see, it is like confusing if your line is all red, right? Like where the line of the current go or where it should lead, and it is really up to you if you're going to change the segment color. Okay, all you have to do is just to choose the line, click right click, and it's optional, right? Okay, like gonna change this one to blue. Okay, and as you can see, this simple RL parallel circuit is like, for me it's really hard to analyze, but it takes a lot of time for us to understood the flow, the uses of all the things that we've, or all the components. Okay, and this one here, this is what I said, oscilloscope, but only 2 channels. And this on the left side, this is what I said, oscilloscope 4 channels. Thank you. In this video, we will use multi-sim transient analysis function to investigate the time domain response of the circuit. This is similar to what we would see with an oscilloscope. So let's start. First things first, okay, we should go to the sources, next we should go to resistor, rated, next another resistor here, and lastly our capacitor. And we should never forget the ground. Okay, I will just gonna place this components first. Here, my resistor here. Okay, this one here. So I will going to search for the ground component. Ground. So it's here. So I will connect everything. Take note, it's up to you if you're going to rotate your components clockwise or counterclockwise. Okay, let's connect this here, and from my resistor 2 to my source. Okay, and the ground. Okay, so as we can see that we go to simulate and search for transient analysis. Okay, we're gonna set this to 0. Okay, zero, and our startup or our starting time is 0.001 millimeter, and our end of time is 0.003 millimeter. Okay, and our output is just, we're gonna pick all of these 3 nodes, V1, 2, and 3, and run. And as you can see, this waveform, this signifies, this red one signifies the V1, and the green one is the V2, and the blue one is the V3. Okay, this signifies their waves or sine waves. Okay, so I'm gonna click, if I click here, so yes, so if you double click the screen, you can see the analysis of the transient analysis. Okay, and you can customize everything, the color segments, their label, texts, and as you can see, it can be edited. So to measure the voltages and phase shifts, we'll use the measurement cursors. Okay, so this is the toolbar button. So excuse me, so this is the first cursor. We're going to set it to the to our time. Okay, and the second cursor is, we should locate the smallest form of wave. Okay, that is prior to 2 milliseconds of the smallest. So as you can see, the readout indicates a time differential about 146 microseconds based on the graph, or based on the cursor. In other words, the small waveform is leading the input waveform by microseconds. So we're just gonna make sure that it's in exact place. I'm gonna put it here. So to get the phase shift, all we have to do is to divide this value by the period of input, that then multiply it by 360 degrees, and it works out that it's about 53 degrees. Okay, So to see the differential voltage, we can add an expression in the transient settings window. So we will go to transient settings window. Okay. As you can see there, the labels. This can be easily identified. So in order for us to add an expression, all we have to do is go again to simulate and go to transient again. So the purpose of this expression is that will be plotted. The possibilities are extensive, right? So as you can see, okay, I'm only differentiating v1 and v2 here. Okay, and creating a new expression. Okay, so add expression. So I'm going to click v1 or node voltage 1, and okay, or copy expression, and then the symbol, which is minus, and the voltage node or node voltage 3. Okay, after that, okay, then I'm just gonna click the new expression and run. And as you can see, there is a new waveform that we possess. This is the new waveform that we've gathered, specifically v1 and v3. So this is the one example of how to create a transient analysis using multisim version 14.3. Thank you.